Hello everybody. Today in the series we are going to discuss basic statistical methods and their application and the measurement of disease frequency in the unit Applied Epidemiology and Public Health in One Health Research. So I am Dr. Shrikant Kanungo, scientist working at RMRC Bhubaneswar. So I am going to discuss these things. So the contents of these lectures will be, I will introduce the topic to you, then the learning objectives, that what are the objectives you are going to achieve in this lecture series, and the measurement of disease frequency, followed by basic statistical methods and their application, and finally I will summarize what I have taught. So as you know that One Health is a collaborative and multidisciplinary approach involving participants from human, animals and environment. So at the end of this session, the learners will be able to understand and use measurements of disease frequency and describe the basic statistical methods, apply this statistical method in One Health research and understand the different tests of significance and their use. So starting with the disease frequency, I will be talking about the incidence. So the incidence refers to the occurrence of the new cases of disease or injury in a population over a specific period of time. So these are the new cases. That means while starting of this any research, the population is not having the disease or the disorder or the conditions, and with follow-up they will develop the cases. That means those are the new cases. So we call them the new cases or the incidence cases. So as I have said, the step 1 will screen about the prevalent cases. The prevalence is something I will talk about in the next slide. And the step 2 will follow up and rescreening after a specific period whether the people without having the disease or disorders are developing the diseases. So this picture of the schematic diagram I have presented from Godey's epidemiology, and you can see that initially the identified populations we have identified, and in that first at the baseline we have done a survey and we have seen this much of people are having the disease. So these are the prevalent cases, these are the old cases, and then we will follow up with the population without having the disease or the disorders. Then if these populations with the follow-up, after the follow-up they are developing any illness or the disease or our desired disease or desired conditions, we call them the new cases or the incidence cases. So you can see that these prevalent cases, these are in the baseline, these are the prevalent cases and the old cases, and after follow-up of those who didn't have the disease, they are developing after the 1 year, this much of the cases they are developing the new cases. These are this population are the new or incidence cases. So this is incidence. So incidences are two types. One is incidence proportion, another is incident rate. So incidence proportion is the proportion of an initially disease-free population that develops disease, becomes injured or dies during a specified period of time. So also called the cumulative incidence proportion risk. So cumulative incidence, which is represented as CI here. So number of new cases of a disease occurring in the population during a specified period of time divided by number of persons who are at risk of developing the disease during that period of time into 1000. So this is the cumulative incidence or incidence proportion. Whereas incidence rate, which is also known as the incidence density, it is defined as the number of new cases of a disease that occurs during a specified period of time in a population at risk of developing disease. So the incidence density or rate per 1000 is equal to number of new cases of a disease occurring in the population during a specified period of time divided by total person time. So this is very important to know. The denominator here we are using person time instead of the number of persons. So the denominator will be the total person time, that is the sum of the time period of observation of each person who has been observed for all or part the entire time period into 1000. So the person time is the unit of time that each individual under observation was at risk. So I will come to one example so it will be more clear to you. So let's see. Suppose in 2021 there are 932 new cases of dengue were reported in a town, and the estimated mid-year population of the town is in 2021 is approximately 3,09,777. So the cumulative incidence or the incidence proportion will be 932 divided by the total population which are at risk, that is the total population of the town, that is 3,09,777 into 1000 is equal to 3.001. At the same time, suppose in another scenario, suppose 4 new cases of illness was reported over about 3 years in a population of 60 persons. So that means we are following 60 persons and these 60 persons are at risk. The following figure represents the duration of the illness of an individual of the person. Suppose person 1 developed illness in the first year, and second and third person developed in the second year, and the fourth person developed in the third year. So we are following up these 60 people up to 3 years. So that means total 60 into 380 person year we are following up. But you can see the first person developed illness in the first year. That means we are not following up that cases when it has been developed a disease. That means it has lost 2 following year. So we are not following these first cases for the next 2 years. And the second and third cases developed in the second year. That means we have not followed them in the next year. That is the third year. And the fourth person developed in the third year. So here we have not followed up 180 person year. We have followed up 170 person year. So the incidence density will be 4 divided by 176 into 1000 is equal to 22.7 per 1000 person year. So this is the difference between incidence rate and incidence per person. So next is measurement of disease frequency, that is prevalence. So prevalence is defined as the number of affected person present in the population at a specific time divided by the number of person in the population at that time. So prevalence is a proportion. So there are 2 types of prevalence. Generally it is point prevalence and period prevalence. So point prevalence of a disease, the number of all current cases means old and new cases. That means those cases which are already been diagnosed and are in the community or in the population, those who have developed recently, those are the new cases of a disease at one point of time, as the name suggested, point prevalence. So at a point of time, what is the prevalence is known as point prevalence. So this is the formula of point prevalence. So in that, number of all current cases of a specified disease at a given point of time divided by estimate population at the same point time into 100. As prevalence is a proportion, so it is, we usually multiply with 100. So prevalence generally refers to a point prevalence. So next is example of this point prevalence. So suppose in August 2001 to October 2001, a research team investigated 27 outbreaks of animals and human anthrax in Ghana, and the team identified 120 animals cases of anthrax and 278 human cases of cutaneous anthrax. So the team investigated total 12,000 animals and 48,000 humans for their investigation, and the prevalence will be 120, that is the number of cases, that is old plus new cases of animal divided by total number of animals who has been investigated, that is 12,000 is equal to 0.01 animal anthrax. So 278 divided by 48,000 is equal to human anthrax prevalence. So at the same time, the period prevalence is, it measures the frequency of all current cases existing during a defined period time, example annual prevalence. Suppose there will be 28 number of asthma cases reported in a 1 year, suppose from 2021 January to 2021 December. So that will be annual prevalence, that is a period prevalence. So expressed in relations to a defined populations. So the period prevalence formula will be number of existing cases of a specified disease during a given period of time interval divided by estimated mid-interval population at risk into 100. As today we are discussing about the quantitative researches, so now I am going to discuss about basic statistical method. So in any research, we start with a population. So the population we call the study population. That means all the individual of our interest is known as the study population. So it is not possible to do the study or measure the whole population. So that's why we have to take a sample from the population, and the sample which we will take from the whole population is known as the sample, and we usually measure the individuals inside the sample, those who are selected to do our study, to do our research. So when we will get some result of the sample, we have to, in turn, we have to generalize the result to the whole population. So this is a two-way procedure. That means we will take a sample from the population and we will measure that sample, and whatever result we will get from the sample as per our interest of the variable, so we will generalize that result to the whole populations. So this is the basics of the statistics. So the statistical methods are nothing but the mathematical formula, model and techniques used to analyze raw data of research purposes and to derive inferences about the population in which the study was conducted. So for that, actually we should know the variable. So what is a variable? Variable are characteristics of the conditions of an individual that can change from individual to individual. So variables, because we have to measure our interest, the outcome, the exposure in our study. So we should know what are the different type of variables. Variables can be a qualitative variable or a quantitative variables. So qualitative variable nothing but the categories. Suppose you are married or not. So the answer will be yes or no. There are two categories. But quantitative, if I will ask those who are married, the number of years you have got married. So that is the quantitative variable. So that means a numeric. So in qualitative variable, it can be nominal or ordinal. Nominal means simple names. So suppose yes, no, or the name of the city, Bhubaneswar, Mumbai, Chennai. So these are the names. So this is nominal variable. But an ordinal variable, there will be certain orders: mild, moderate, severe, taller, smaller. So these are the different orders. So the qualitative variable can be nominal or ordinal. But at the same time, quantitative variable are discrete or continuous based on the counting. If you can count the quantitative variable, it is a discrete. If we have to measure that variable, it is a continuous variable. As for example, suppose we want to see the antimicrobial resistance, the number of drugs a sample is resistant to. So suppose there will be, the sample is resistant to two antibiotics. So we can say 2 antibiotics. So suppose one sample is resistant to 3 antibiotics. So there are the counts of antibiotics the sample is resistant. So this is a discrete variable. But continuous variable is, suppose age. My age is 23.5 years. Suppose my height is 178.5 centimeters. So we have to measure it. So these are continuous variable. So if I will summarize this, the variables are two types. One is qualitative variable, another is quantitative variable. Qualitative variable can be nominal variable and ordinal variable, and quantitative variable can be discrete variable or continuous variable. So basic statistical method which are used in the different research, these are two types. One is descriptive statistics, another is inferential statistics. So descriptive statistics are to summarize, organize or simplify the data, and inferential statistics to study the sample and then generalize about the population from which they were selected. So if we will see the types of statistics, generally the descriptive statistics for the quantitative variable are mean, median or mode. These are the central tendency, they are the central value. So mean is the simple average of the distribution, the values of the distribution, and median is the central value, and mode is the most frequently occurred values in the distribution. And the dispersions are maybe range, that means from minimum to maximum value, or the standard deviation or the variability. The standard deviation is the individual values, how it is deviated from the central value, that is called standard deviations. So in the inferential statistics, there are two things. One is confidence interval, another is hypothesis testing, that is statistical test of significance. So first we will discuss about descriptive statistics for the categorical variable. So descriptive statistics for categorical variable can be expressed in terms of ratio, rates and the proportion. So the ratio that is nothing but a comparison of two values that is obtained by dividing one number by simple another number, and these two numbers are independent of each other, then that time we will call that is a ratio. So based on the relatedness of the numerator and the denominator, when the numerator is included in the denominator, we call these things are rates or proportion. So rate, a measure of frequency of an event in a defined population over a period of time, is known as the rate, and it has two distinguished characters. One is the time and the multiplier. That means that rate must have one time factor and a multiplier. In the proportion, it is a comparison of a population to whole. That means in proportion, the numerator is a part of the denominator, and this measures a fraction of people having disease out of all the population at the risk. So you can say that prevalence is a proportion. But when we will calculate the incidence in a certain period of time, so it will be a rate. So this is an algorithm for distinguish rates, proportion and ratio. So ratio is simple when the numerator is not the part of the denominator, so that is a ratio. But when numerator is a part of the denominator, that time it can be a rate or it can be a proportion. So if the time is included in the denominator, we call it is a rate, but when the time is not included in the denominator, it is a proportion. So these are the examples of rate, ratio and proportion. This is very important in the quantitative research and in the expression of the results of the quantitative research. So next we are going to discuss about hypothesis testing and p-value. So before that, I will talk about what is hypothesis. So hypothesis, it is the transformation of a research question into an operational analog. That means what we are going to prove. Suppose as for example, misuse of antibiotic can lead to antimicrobial resistance, or the methicillin resistant Staphylococcus aureus can cause more death than the methicillin sensitive Staphylococcus aureus infection. So these are the different research questions that can be put in a form of statement that need to be proved or disproved. So that is a hypothesis. So in negative sense, we can call it a null hypothesis. There is no difference in the risk of lung cancer and smokers and non-smokers. So this is an example of null hypothesis. But alternate hypothesis, this is the difference. There is a difference in the risk of lung cancer among smokers and non-smokers. Usually in the statistics, we start from the null hypothesis. We usually put the null hypothesis statement and we collect information and evidence to disprove or prove it. So based on our evidences, we test whether the null hypothesis is rejected or accepted. So in this process, usually there are 4 outcomes can happen. That means suppose the null hypothesis is really true, but we will find it is not true, or null hypothesis is false, but we will find it true. So in these cases, we can there can be some errors. So these are alpha errors or beta errors. You can see in the example, suppose in truth there is no association between one exposure variable, another outcome variable. But in a study, we will find there is an association. That means we will commit one mistake or one error. So that error is known as type 1 error or alpha error. And if there is no association, but we will find there is an association, but we will find there is no association. So in that condition, that is called type 2 error. So p-value, what is p-value? So p-value is the probability that the result is just by chance, and it is nothing but the alpha error. And when we conclude that there is an association, but in reality there is no association, that is an alpha error, and that is the probability of the alpha error is known as p-value. So lower the p-value, more confident that the researcher about the significance of the result, difference and the association. Application of the statistical methods. First, there are different steps how to use the statistical methods or the test of significance. So first, determine the type of variable used as exposure or independent and outcome or the dependent variable. So let me explain what are the exposure variable and what is the outcome variable. In a hypothesis, suppose we are putting one hypothesis that misuse of antibiotic can lead to antimicrobial resistance in the population. So in that case, the exposure is misuse of antibiotics and the outcome is that antimicrobial resistance. If I am putting another hypothesis, that is methicillin resistant Staphylococcus aureus the infection has bad outcome, then the methicillin sensitive Staphylococcus aureus, that means there is a association between the methicillin resistance or sensitive with the mortality. So in that cases, the exposure will be methicillin resistance or methicillin sensitive, and the outcome will be the death. So this is the exposure and the outcome variable. We have to find out what type of exposure variable is there and what type of outcome variable is there, and then we have to find out the distribution of the data. So in this session, I am not going to tell about the distribution of the data, but we must understand the distribution of any variable or any continuous variable. It can be a normal distribution or it is a non-normal distribution. There are certain methods we usually do that to find out the normality of a distribution. Then we have to describe the data in terms of the descriptive statistics. That means we have to use based on the variable what kind of descriptive statistics method we can use or the measurement we can use, and then we have to finally apply the statistical test to compare. So these are the what I have discussed now, the variables. It can be dependent variable or outcome variable, and independent variable or exposure variable. So dependent variable can be a discrete variable or categorical variable, or it can be a continuous variable. Similarly, the independent variable also can be the categorical variable or a continuous variable. So now look at this picture. So the outcome variable, if it is a continuous variable, and the exposure variable is a categorical variable or a continuous variable. So based on the comparison, how many groups we are comparing? Suppose there is one group we are comparing, then we have to apply sample t-test, one sample t-test. If there are two related groups, that means before or after we are looking at the values, so then it will be a paired sample t-test. If there are two independent groups, or then we will use unpaired sample t-test. If there are more than two independent groups, we can use ANOVA test. If the exposure variable is also a continuous variable and outcome variable is a continuous variable, we can use the Pearson correlation test. So all these things what I am telling, these are parametric tests, and we are assuming that the data is normally distributed and data should be continuous, that is the outcome variable, and homogeneity of the variance. Next, we can see there are different tests if the data is non-normal. That means data does not follow the normal distributions. So in that cases, these are the tests. So if there is one group, then we can use Wilcoxon sign rank test. There is two related groups, we use paired Wilcoxon sign rank test. If two independent groups are there, we can use Mann-Whitney test, and more than two independent groups, we can use Kruskal-Wallis test. And if both the variables are continuous variable, the outcome variable and exposure variable, we use Spearman rank test. Let's summarize the today's session. So today we have discussed measures of disease frequency, incidence and prevalence. Also we have seen in this session there are different type of incidences, that is incidence rate and incidence cumulative incidence and point prevalence and period prevalence. Then actually we have discussed there are different statistical method, the descriptive statistical method and the inferential statistical method. Then different types of variables and statistics, application of the statistical method based on the variables, and assumption of parametric and non-parametric tests. With this, I will stop this session.